This is the answer key for calculating empirical formulas. We need to understand that an empirical formula is the smallest whole number mole ratio, which means that we need to get moles and we need to turn these into whole numbers, which makes these two steps. Inside the problem, we need to take the mass that's provided to us, divide that mass by the molar mass of that atom. The molar mass of that atom is going to come off our periodic table. So for the case of strontium, strontium weighs 87.62. We can find that on our periodic table. We're going to take the 15.73 divided by 87.62. That's going to give us a mole value. We need to take the 46.01 grams of iodine, find iodine's mass in the periodic table, which is 126.9. So 1 mole of iodine weighs 126.9. And divide those. That'll give us the moles of each substance. In our calculator, plug these values in. 15.73 divided by 87.62 gives me 0.1795. 46.01 divided by the 126.9 is 0.363. So we just got the mole values. This is moles of strontium, this is moles of iodine, but it's not a whole number. So we need to divide both of these mole values by the smaller of these two answers, and that'll turn both of the numbers into whole numbers. So divide by the 0.1795, because that's the smaller of the two answers. Any number divided by itself is 1, so we have effectively 1 mole of strontium. And then the 0.3625, which is basically this number, divided by 0.1795 is right about 2. Close enough to 2 with rounding that we can call it 2 moles of iodine. For the empirical formula, we will take these mole ratios, 1 mole to 2 moles, and those become the subscripts of our formula. Metals go first in formulas, so we go metal to nonmetal, a 1 to 2 ratio. Ionic compounds, in just about all cases, the formula is the empirical formula. Problem number 2, we have 589.2 grams of carbon and 97.01 grams of hydrogen. Take each mass value divided by the molar mass of each substance. My periodic table tells me carbon weighs 12.01. 9701 divided by periodic says 1.01 grams of hydrogen. Just divide these two out. .06. 9701 divided by 101. 96.05. So this is moles of carbon, this is moles of hydrogen. We need to have the smallest, so these aren't small, whole number mole ratios, so we need to divide by the smaller of these two numbers, which is 4906. So we will have 1 mole of carbon divided by 4906. So again, we're basically at the value that we're supposed to be at, just a little bit of rounding, divided by 4906. And that is just about 2, close enough to 2. So that makes 2 moles of hydrogen, which makes it a CH subscript 2 empirical formula. Problem number 3. Strong acids made by combining 4.63 grams of hydrogen. Divide that by hydrogen's mass. We just use that, 1.01. That's coming off the periodic table. 73.55 grams of sulfur. Periodic says that sulfur weighs 3206. It's right here. And then 146.43 of oxygen. Oxygen periodic says 1600. 4.63 divided by the 1.01, 4.58. And that would be moles of hydrogen. 73.55 divided by the 3206 equals 2.29. That's moles of sulfur. And then the 146.43 divided by 16 is 9.15. And that would be moles of O. Now, these aren't the smallest, nor are they whole numbers, so divide them all by the small. And it rhymes a little bit. So 2.29 is the smallest with three values. .58 divided by 0.29 is just about 2. You can look at that, see that, or you can plug that in your calculator. Any number divided by itself is 1. And then 2.29 divided by 9.15 divided by 2.29 should be right about 4. So 2 moles of H, H subscript 2, 1 mole of S, 4 moles of O, we make something called sulfuric acid. An ionic compound is made by adding 5.68 grams of O, 1.62 grams of N, 6.55 grams of Fe. 5.68 grams of O divided by O's mass, which is 1600, 1.62 grams N. Nitrogen's mass is 1401. Then iron, 6.55 divided by 55.85. That's what the periodic table says iron's mass is, right here. Plug these numbers in. 5.68 divided by 16 equals 0.355. 1.62 divided by 1401, 0.116, and then 6.55 divided by the 5585, 1.17. Of these three numbers, nitrogen's mole value, this is 0.116 moles, is the smallest. Divide them all by the small. Oops, decimal in the wrong spot there. These numbers are basically being divided by themselves, so we have 1 mole of N, 1 mole of Fe, and then the 0.355 divided by 0.116 is just about 3. As far as formulas go, we want to put the metal first, so Fe, and then oxygen tends to go last. 1 mole of Fe, 1 mole of N, 3 moles of O, subscript 3, box that answer. For number 5, an ionic compounds formula must also be the empirical formula. For our class, that's basically true. There are a few exceptions, but we're not really using those ions, those examples in our class. A covalent compounds formula must also be the empirical formula. This is false. We can change this to may also, or often is, but does not have to be. An empirical formula is the smallest decimal mole ratio of elements in the compound. That's false. This is the smallest, as we know, whole number ratio of elements in the compound. So those are the answers to the worksheet calculating empirical